date. The format will be post book, post notes, but you are now to bring in one formula sheet, half a page. You can write down anything you like for test 1. Test 2, same sheet of paper, full page. So the bottom half will be reserved for test 2. Again, you can put down anything you like. It will not be collected, it will not be graded. It's just your formula sheet. Final exam, one full page, front and back. So you can use the same sheet of paper and continue to build on that. Right? You are welcome to bring a text in case if you think something may be missing in the problem statement, but it shouldn't. That's entirely up to you. If you think you need permission to use the table in the back or anything, constances, you can raise your hand to ask for permission. But I can tell you when that happens, you're probably on the wrong path. Right? The test is self-contained. Everything you need should be there. Okay? All right, we'll say more about that as we get closer. Agenda today is to first and foremost clarify any question you have on 1D momentum equation. How to draw the control rod. What happened to the pressure? Why do you use gauge as opposed to absolute? So on and so forth. And to that effect, the quiz, I will go over that and answer the question you have for today's homework. Incidentally, we apologize we haven't posted the solution to the homework as intended. So moving forward, we're going to correct for that. How many of you have actually actively looked at calories? Please honestly raise your hand. So half the class, okay? You have to get the habit of looking at that every day or every lecture. All right? In addition to post-it lecture, you may or may not need that. We will have video of the lecture itself, which obviously I don't want you to look at it because it's an hour. You just don't have that time. All right? It's just for my future potential use if I miss classes. But if you need to, you can look at it. But more importantly is all the other announcement, homework assignment, and most critically, the homework solution. On this class, you cannot afford to stay behind. So as soon as the homework is due, like today, the set that's due today, if I were you, I would look at those solutions, even though you think you have done it correct. And you know the numerical answer in the back of the text, I think for the either odd or even number are given. Have you looked at that? Are you aware of that? No. So I thought I have told you the first lecture is to look at your textbook, the first few pages, and all the appendix in the back. So you haven't done that. You know, all this will cost you. So do that, because the answer are given for some of the, I think either the even number or the odd number, so you can check yourself. But you can't just do the homework and assume you've done it right. And that's why we post the homework solution. So to be preparing for the test, you must know how to do the homework, period. That's the minimum. I think it's obvious, you know. In the homework, and the quiz will, the test will be one step beyond that, which means the problem will be more difficult. Do I make myself clear? So how many of you have actually looked at the homework solution for those only 2 that were posted? I think the rest of you need to really pay a bit more attention to that. All right, so moving forward, every day after the lecture, the solution to the homework will be posted. And it's up to you to look at it, up to you to ask me questions. And in the lecture or at the office hour, ask Mike if you're not clear of the solution, why it's being done that way. All right, so I just keep repeating myself, but I learned from experience if you don't do that, you're going to have a rude awakening in the test. Okay? I hate to be so forceful, but I learned from experience there's so many places you can be confused. Okay, so having said all of that, I will also touch on the new homework for the 1D problem. And the rest of the lecture, more than an hour, preferably. First, we'll be going over that 2D plate problem that I asked you to read. Again, the reading assignment is such that if you don't read it, you come to class, you won't be prepared. You have no idea what I'm going through and what question you want to ask. So please, the assignment is there for a reason, and I'd like you to follow that. The plate problem is very important. If you know how to do that, you're probably all set for the test. But if you don't, you need to find out how to do it. And then I make sure I have like 5 minutes left at the end of class to go over the new homework, which is on 2D momentum equation. It's a little bit more involved and more confusing, but again, you have to make sure you can do the 1D before you can touch the 2D. Assignment reading is on the Reynolds transport theorem. We started that last time. Chapter 4, session 4. Homework 3 hours. Another set is, we'll talk about that in the next lecture, but it's just giving you in advance what it should be. So let me stop and answer any question you may have in any regard. No? Okay, so the quiz has not been graded yet. Once it's graded, we'll return back to you. And we'll try our very best to return material to you in a timely manner. You're all students. So quizzes, I like to have the policy that we'll return in the next lecture. And that test, we try to return that back to you within 1 week. All right, because you need that feedback. So this is a problem that I think is, I hope, it's a walk in the park. And the solution for the forces, while the intermediate step using the coordinate given in the problem statement. Just make sure you understand all the sign. Do I have anyone who want to have me go through that step by step? Yes, okay. Be very honest. Don't worry about feel uncomfortable asking questions, because I want you to. So as defined in the problem statement, everything is very clear cut. Control volume is given, the force of direction is given, x, y coordinate is given. In the test, you may not have that issue. You may or may not be given any of this. So you have to be prepared to do it on your own, right? So but with this being defined clearly, the x momentum equation 1D is spelled out forces on the left, summation, all what are the 3 components, categories? Surface forces, other 2, anchoring forces, and the last one? Body forces, okay? M dot U out minus M dot U in. The sign is always out minus in. And the M dot is a scalar, low VA, no direction, no sign. U is the velocity parallel to the x direction with the appropriate sign. So as such, I have M dot out, which is this station. Velocity is pointing opposite to plus x, so it's minus v. Do you see it? This minus sign represents the incoming momentum flux. That's what we call this term, M dot U. And this M dot, no sign again, and this will be repeated in the 2D problem momentarily. So if you have a problem now, you better ask. The velocity coming in this station is positive x, and hence is plus. Any question on the left-hand side? Yes?
Could you repeat why there's a minus sign between the 2 terms?
This minus sign is the result of the Reynolds transport theorem. And the way it come about, I have to go back to the continuity equation. But in the big picture sense, to answer your question, is the way we define quantity to be positive and negative. All right, the more detailed derivation of this equation, which I haven't done, will be next lecture or beyond. And at that point, I will revisit